Yeah.
Can you see and hear us?
Can you see and hear us? Oh. Ja, maar ik ben aan het. Alles is.
Yes, perfect, Ben.
Ja, maar hij heeft hem 2 keer.
There is a bit echo of from Maastricht, I guess.
Ja,
Okay, the event is on air. So we are.
Who has the presentation now open? Wacht, do you have the presentation open, or John?
Okay. Do you want me to share? Perfect.
Yeah, do you share and then we talk? Is that okay?
Perfect.
Or else we have to, je hebt de presentatie niet, hè?
Nee.
Are we on air? Yes. Okay.
Yes, the stage is yours.
So I would like to welcome everyone for this open market consultation meeting from the Netherlands. Maybe it's good to start with a short round to tell each other who we are. I'll start myself. I'm Erna Hofs. I'm Program Manager Sustainability and Environment at the Maastricht University Medical Center.
My name is Ben Jansen. I'm a researcher and I'm helping to get rid of the medicinal waste of the hospital. That's my task.
My name is Harry Domen. I am the contract manager for the technical department.
Good morning, everybody. Robert Dijkers, team leader of energy, resources, and the monitoring for MUMC.
My name is Marcel Nijsten, team lead of maintenance department, installations and buildings.
Morning, Frank Saita, radiologist and project leader of within the Green Deal regarding PM5, so medication waste in the wastewater.
Paul Zegers, technical buyer at Maastricht. Morning.
And people online. Oh, okay. Well, we start with a welcome, house rules, what Theresa is aiming for, technical aspects, what is an open market consultation, and the participating hospital context. So who are we and what do we do, and what's important for a possible supplier that we will cooperate with in the future. Next slide, please. Oh, well, that part we skipped. Well, we've had already. Well, the house rules, this event will be recorded and it will be published on YouTube on the website from the Theresa website. Please, if you have any questions, please write them in the chat, or we can just write them for you if you wish. And the list of participants will be in the webinar of this webinar, will not be dismissed. This will share. Okay. Now I'd like to tell you something about our hospital, some background information, and about our sustainability program that we have. Next slide, please. Our hospital has approximately 3,500 patients in our hospital hospitalized every year. Day treatments is like 24,700. The average stay of a patient in our hospital is approximately 5 days. We have 546 beds in our hospital, 15 surgical rooms, yes, and nearly 3,000 outpatient visits, clinics. And the visits to our emergency rooms is like 31,500 a year. Next slide. Well, in the Netherlands, we work with the Green Deal Sustainable Healthcare. It's 3.0. And that's a Green Deal. We work on 5 pillars. And it's signed in November 22nd, 22 by the Dutch Federation for the University Hospitals. So on behalf of all the university medical centers in the Netherlands. But besides the UMCs, also cure and care sector is part of the Green Deal. Government, of course, insurance companies or health insurance companies and financial institutions. So it's a broad group that works on the Green Deal 3.0. I would like to tell you a little bit more about the 5 pillars. So if we can go to the next slide. The first pillar is promoting health or well-being, better known. It's about healthy food, healthy living, moving, quit smoking, and those topics. I'll be short on the first few pillars. Maybe the next pillar, pillar 2, next slide, please. Pillar 2 is promoting awareness and knowledge. It's very specific, especially for a university medical center, because we have a big role in creating the next generation, of course, educating the next generation, and not just doctors, but also nurses and other staff members. Pillar 3 is reducing carbon dioxide emissions from building, energy, and transport or mobility. We have the target to reduce our emissions by 55% in 2030 and 95% in 2050. To get there, we've made a roadmap. And as you can see on the picture or the figure on the right side, the orange line is, well, the plan where we have to go to, and the blue line is where we are at the moment. So it's a nice progress, and well, it's possible to reach the goal, but it will be challenging, of course. Okay, yes. Pillar 4 is about circularity, and as you can see, we don't produce things, and we're not recycling things, but we use the products. So what do we do in that? Well, we look at everything that we use and we ask ourselves, do we really have to use this new material or this virgin material, or can we use reusable materials? The things that we use, we might use them a bit longer, and if we cannot use it anymore, we have to think about closing the cycle, closing the loop. And not at the end of the program, but in the beginning when we buy things already. And on the picture on the right side, you can see a new building we are building. We are starting to build it at the end of this year, and it will be a wooden structure building, and it will be the first wooden structure building in the Netherlands. And the garden in front of it is actually an extra level that we will create on top of our parking garage. And it will be accessible for staff, but also for patients. So we're very proud of this project. And last but not least, we have pillar 5, and that's the pillar why we are all gathered here together. So if the next slide, yes. And that's about reducing the environmental impact of medication use. So it's a very broad topic. We look at medication. Do we have to use this medication? Can we make greener choices in this medication? But from all the medication that we use, we also have to think about filtering it out of the wastewater. And that's actually why we joined this project. What's good to know is that for here in the Netherlands, only 3.5% of the medicine that ends up in the wastewater is actually directly coming from hospitals. It's like 90% is coming from people's homes. Next slide, please. Well, maybe a bit more about how we do it, the topic of sustainability in the hospital. As you can see, we have the ISO 14001 certification. We already have it since 2005. So taking care of the environment is not new for us. It's something that we are doing already a long time. But we want to do more than just the environmental care. It's a broad topic like sustainability now. Next slide, please. Where did we start? Well, we have made a carbon dioxide footprint from the data from 2022. I hope to make an update from the data with 2025. And this gives us a good picture from where we can find our carbon dioxide emissions in scope 1, 2, and 3. But it helps us also to make the choices where we should prioritize in projects, what we should do first, and where we can reach the most impact. Next slide, please. Well, and how do we do these projects in hospital? We do it bottom up and top down. Top down, we have steering group and different project groups, and bottom up, we have green teams. Just a little bit more information about that on the next slide, please. Well, because we have 5 pillars in circularity in the Green Deal, we have 6 project groups, and that's because carbon dioxide emission reduction, we split up because energy and buildings is really different from transport. So that's why we have 2 groups. But the most important for this meeting is the last one, and you will recognize Frank because he's our project leader on project 5, project 6.
To make it more complex.
Yes. And then I think it will be my last slide, please. A bit more background information about our green teams. I even should add to this picture, we have like 18 green teams at the moment. And those green teams are teams from doctors and nurses and staff from departments that cooperate together to greener their own working environment and their own department, so on a small scale. And if they have good ideas that can be wider or broader in the organization, we match them to our project groups and we try to implement them on a bigger scale. And I think that was my last slide. Yes. Now John can take over, I think.
Thanks to all of you, and I'm taking over. I'm trying to share my screen. Okay, please let me know if it works.
Yes, John.
Yeah, I'm putting it in a presentation mode. I hope it is working. Yeah. Okay, I'm Johnny Zaguirre, and I'm part of the Fundación Miguel Servet and Hospital Universitario de Navarra, that we are coordinating the project, and we are working alongside Maastricht Hospital and the rest of the partners in this Theresa project. I'm talking briefly about what Theresa is aiming for. Okay, so we are trying to explain it. Maybe you may probably already know it, but we are trying to make it a bit more clear, and as in every other event, any question that may arise, we will try to answer it at the end of the session. Okay. The project Theresa has a surname which is PCP. Okay, it means that it is a pre-commercial procurement project funded by Horizon Europe program. Okay, we are working in this project through different public with different public organizations, different hospitals, and some different partners. Okay, in collaboration with the market to try to develop and test innovative solutions that are not already available in the market. Okay, so that is an important idea, that we are looking for solutions that don't exist or at least don't cover the full scope of the project's objectives. Okay, we have 2.9 million for this for this project. Okay, for the whole PCP process. So this is the available budget
John,
for the
may
different.
I interrupt you for a moment?
Yeah.
Yes, Marcel has let us know. Well, we see it as well. We see the presentation mode of your presentation on the screen, so it's very small.
Okay. Okay.
Can you adjust that, please?
Yeah, I can share it differently. Yeah, because sometimes it. Just let me share it again. Excuse me. I will do it like this because otherwise it may happen the same. Sometimes it happens, so I don't know really why. Okay,
Okay,
but yeah.
it's better now. Thank you.
Thank you for telling me. As I was saying, we have an objective that at the end is trying to reduce or eliminate the the different contaminants that are released in hospital wastewater. Okay, as you may know, hospitals are a hotspot for pharmaceuticals, pathogens, cancer drugs, contrast agents, and different elements that create antibiotic resistance. Okay, so we are trying to tackle all these contaminants or all these different sources of harm into the environment. The thing here is that conventional treatment plants cannot really remove all these substances at the same time. They don't have the technology, and or if this technology exists, is really expensive and is not installed yet in this wastewater treatment plant. So these contaminants reach the rivers, the soil, and ultimately, as you can see here, the food and drinking water. So it is a big concern, and we are trying to tackle it. We have focused on different group of contaminants. Okay, and these are the ones that we are trying to reduce. We are talking about the cytostatics, X-ray contrast agents, and antibiotics, and also the different antibiotic-resistant bacteria and genes. Okay, we have been working in the first months of the project trying to develop these lists of contaminants regarding their impact in the environment. Also, we have looked at the different consumption rates in each hospital. We have identified different cytostatics, different contrast agents, different antibiotics regarding their clinical impact or ecotoxic impact. So that is the work that we have been doing the first month of the project, and we have further developed this list in the questionnaire that will be explained later. We need the help of the suppliers to really know if these contaminants that we have addressed are viable, if it makes sense, if we are asking too much, or if they have the technology to tackle it. Okay. The goal of the project, as I was saying, is to try to reduce or eliminate all these contaminants, and at the same time, we are looking for different requisites in our technologies. Okay, we need them to be modular. Okay, it means that it's also scalable and adjustable, because in the project we are testing in lab facilities, then also in pilot. It would be also a pilot setting. So we need that technologies that are able to adapt to these different scales, and also to the different locations of the hospitals, because we are talking about 7 different hospitals. All of them won't test the technology, but in the end, all the hospitals belong to the buyers group that would be interested into acquiring, if a successful technology, in case we are able to get it. Okay. As I said, we should target the priority contaminant groups, and they have to demonstrate that it is technically feasible, that cost effectiveness and readiness for integration into real world infrastructures are a reality. Okay. As I was saying, we work with different hospitals in this project. We are 7 hospitals from different countries all over Europe, and today Maastricht Hospital hosts this event. But we have also SAS from Belgium. We have WSS from Poland. We have PER from Estonia, and 3 Spanish hospitals, Virgen de la Macarena from Sevilla, Consorci Hospitalari de Vic from Catalonia, and ourselves from Hospital Universitario de Navarra from Navarra. And as I was saying, we're a big group a big working group. So all these 7 hospitals are working all together with different supporting partners, okay, that have the knowledge about different needs that we have in a project like this. We have Silo, Healthcare Without Harm, Corber, Stick Biomed, Sanin, and Yetu, that are very that create a great and complete team that makes possible that we hospitals don't go alone in this difficult and complex project. So that would be it. Now I leave the floor to the technical aspects of the Netherlands. Okay. Yeah. I share my screen, and as I said before, any question that may arise, just let us know through the chat or through the Q&A section, and we will try to answer it later. Thank you.
Okay, thank you, John. So it's time for Luna to address the technical aspects for this event. So Luna, do you want me to share, right?
I think it's Isabella. She pre-recorded a presentation. If you can play it first, and then I can present my part.
Okay, perfect. I'm sharing the Isabella part. Okay. Okay. It has audio on it, so are you hearing Isabel, right?
I am from the Environmental Technology Verification Body. So,
are you hearing her?
Yeah.
Okay. Okay, let me restart.
Hello, good morning. Hello, good morning, everybody. My name is Izabela Ratman-Kłosińska. I am from the Environmental Technology Verification Body from the Institute for Ecology of Industrial Areas in Katowice. Today, I would like to present to you a little bit on the framework that we're going to use for the assessment, verification, and the validation of the PCP Theresa solutions with dedicated focus on the technical verification approach that we're going to use. I apologize that I cannot be with you today in person. This is due to the traveling. Nevertheless, I hope that the information I will provide today will give you an understanding on how we are going to approach the assessment of the PCP solutions at the individual procurement stages. So the technical verification approach actually establishes the conditions for which we're going to evaluate the solutions in the different PCP stages. Here, I would like to highlight that for the PCP phase 2 and 3, we'll be using a standardized approach, which is described in the ICO 14034 Environmental Technology Verification Standard that I will present to you in this presentation. And that will allow us to provide objective evidence for the whole consortium to verify that the prototypes that are being designed in phase 1 actually meet the desired technical and functional as well as environmental performance requirements. So the Theresa PCP includes 3 phases: the solution design, the prototype development, and the original development of a limited volume of first products. And for each of these phases, we have defined specific timelines, the TRL levels, including enter TRL level and expected exit TRL level, the scope, the objectives, and of course the testing environment and the related requirements. I will present them in the next slides. Let's begin with PCP phase 1. The duration assumed for this phase is 3 months. The objective is to assess the technical, economic, and organizational feasibility of the innovative solutions and to select the most robust designs for phase 2, which is the prototyping phase. What we will expect here is a complete system architecture and its design, including any documentation like blueprints, presenting the components, the processes, the algorithms, expected environmental impacts of the system. It will be also important to have a defined monitoring and measurement concept presented, including the operational parameters, which of course will be technology specific depending on what kinds of unit processes you are going to involve in the system, the monitoring for the effluent quality, the quality of wastewater for reuse if you're assuming that in your system, and of course the monitoring of the removal of the Theresa PCP target contaminants, which is critical to define the actual performance of your system. So the solutions here will be evaluated on their ability to credibly progress to the prototyping stage and the feasibility to meet the Theresa PCP KPIs, about which I will tell at the end of my presentation. At this stage, we're not expecting any testing. However, it would be beneficial to have any test data to substantiate the feasibility of the system design to deliver the claimed performance. The expected exit TRL level is 5 to 6, which means that the technology components have to be integrated with realistic support elements. So the complete system design is feasible to perform to meet the key performance indicators. Concerning PCP phase 2, the expected duration for this phase is 10 months. The objective here is to develop and experimentally validate the functional prototypes and to demonstrate the measurable technical performance under controlled conditions. We are expecting here the prototypes development based on the phase 1 designs, of course, including also the monitoring concept, and the performance to be tested against a verification plan, testing protocols, based on the agreed KPIs framework, and criteria including quality assessment and quality control that refers especially to the testing requirements. The prototypes, the solutions will be evaluated in particular on their performance, technical, functional, environmental, and performance, and the interaction with the realistic conditions and operational environment at the hospitals. Here we'll have already the testing phase. The prototype, it will include prototype laboratory testing of performance based on those test plans and KPIs and quality assurance and control systems. The testing will be performed at the premises of SAS, in particular Hospital Virgen de la Macarena in Spain. The testing will be performed as indicated in control simulated conditions. However, they have to be representative to the PCP Theresa Hospital conditions. We'll also assess here the potential for the integration with the operational environment of the hospitals. The expected exit TRL level is 6 to 7, which means that the prototype system demonstrated in an operationally relevant environment. For the PCP phase 2, again, the duration assumed is 10 months. And the objective here is to validate the final solutions in real hospital environments in order to verify their declared performance, their robustness, and to confirm their readiness for the deployment. The scope includes real-world testing under diverse hospital-specific conditions to verify the performance claims related, of course, to the technical, functional, and environmental performance following the ICO 14034 ETV process. Also to prove the environmental, economic, and social added value of those solutions, and also to demonstrate the full integration capability with the environmental, with the operational environment of the hospitals, including the system control and the monitoring. So here the solutions, which will be no longer prototypes, but pilots in their final form, which means we're talking here about complete systems, will be tested and validated under defined conditions of application to check their actual achievement of the declared technical, functional, and environmental performance. And that will be done based on a factual approach using independently produced test data under real conditions of application, and also to check if they meet the end user needs in terms of economic, social, and integration with the operational environment. Here we'll have, again, a testing phase. The testing will be based on the deployment and the validation of two most promising solutions in 4 hospitals. You have those hospitals listed on the slides. So there will be hospital in Spain, in Netherlands, in Estonia, and in Poland. At this stage, all the systems must be integrated in the real-world operational environments of the hospitals. The performance verification will be based on technology-specific verification plans and test plans that will be integrated with the KPIs. All the test data must be generated under restrictive quality assurance and control rules compliant to ICO 17025 standard, which basically means that accredited laboratories will need to be involved at that stage. And of course, they will need to be related to the on-site conditions of the hospitals in which the testings will be done. Then we'll use the third-party verification under ICO 14034 ETV standard to confirm the performance claims. The exit TRL for this stage is 7 to 8, which means that the pilot system is demonstrated in a real-world environment. Now, let me explain why we're using this ETV scheme in Theresa PCP. ETV is a scheme that consists in proving in an impartial and credible way that the claims that are made by the technology providers about performance of innovative environmental technologies are true and are based on sound scientific data. The verification under ICO 14034 ETV has some specific features that make this scheme especially appropriate for innovative technologies. First of all, the approach is standardized by an ICO standard. It is robust and transparent, and it's technology neutral. This is a standard that is from the group of environmental management standards. And because it has been approved by ICO, and this is also a European standard, it is recognized in the EU and globally. The second feature of ETV is the quality and the impartiality that is assured by the process. The whole verification scheme is based actually on two well-recognized quality assurance and compliance standards. First of all, it requires that the test data that are used for the verification are generated under the conditions of ICO 17025 standard. This is a standard that you may know because it refers to the laboratories and their work. And the second thing is that the verifications are performed by verification bodies like ours at the Institute for Ecology of Industrial Areas that need to be accredited to ICO standard 17020. This is a standard for inspection bodies. And we are accredited under the most restrictive rules of impartiality, which means accreditation for type A inspection bodies that allows us to ensure full impartiality of the professional judgments that we're making. And the third very important feature is the fact that ETV is fit for early market innovations, which is the case for Theresa PCP, because it allows to verify what is most important about the performance of a technology to demonstrate its innovation towards the buyers and towards the users. Unlike compliance schemes, ETV is flexible in terms of the choice of performance parameters to be verified. So these could be adjusted, for example, to our KPIs. And it also enables proving the performance claims of technologies that cannot be verified in any other way because there are no existing regulations or standards or different labeling schemes that could reflect this performance. And this is also the case for Theresa PCP because we do not have a standards right now for the removal of the target contaminants that are in the focus on Theresa PCP. So to summarize why ETV in the Theresa PCP is that, first of all, the scheme defines at the level of an international standard on what is an environmental technology, which means technology that results in a less adverse or positive impact on the environment compared to solutions to which it is an alternative. It also defines, ETV also defines the term of the environmental added value, which is an indicator if a technology really results in this reduced impacts, and it also regulates that at a standard level. Moreover, ETV allows to verify new, even disruptive technologies, and this is what we're expecting here under this pre-commercial procurement that could demonstrate unique technical, functional, environmental performance, and this is because of the rule of this flexibility. Fourth, ETV defines a process for technology performance claims verification and the claimed environmental benefits that allows also to verify the assessment of the technology maturity. So that refers to the TRL level. its innovation, proving its innovation, considering also all the assumptions and constraints and limitations that are related to the technology application and its scalability, which is again the case for Theresa PCP. It also ensures that all these assessments are being done with adequate quality, credibility, and impartiality, which builds trust for the users of this information, and in particular the buyers, the clients, but also for the regulatory purposes. The central elements of ETV are the performance claims, which are, technically speaking, a set of technical specifications that represents the functional, technical, and environmental performance of the technology that are defined for specified application and under specified conditions of testing or use. That will be also the case for Theresa PCP because we'll be testing the technologies under specified conditions of the hospitals. And of course, test data on the performance that needs to be collected that will be done throughout phase 2 and phase 3 with the purpose of phase 3 to deliver data that can be independently verified following the requirements of ICO 14034 standard. How do we envisage the implementation of the ETV scheme in the Theresa PCP? Again, this is not fixed yet. Nevertheless, I wanted just to highlight with this slide what benefits and what elements of the system might be integrated into PCP phase 2 and 3. First of all, for PCP phase 2, we'll look into establishing a common background for the definition of the intended application of the technology on the basis for the assessment of the environmental added value, and that means the environmental identification of the key environmental impacts of the technology. Also, the common approach for the definition of the initial performance claim, and it's, of course, alignment with the user's needs. We'll be also using this approach to provide guidance and to get from you a clear understanding on the technology constraints and limitations, because this is extremely relevant for the future technology users to get a clear understanding if this technology will work in their operational environments. And of course, something that is subject to the verification, this is the specification of the performance parameters that are to be verified. We'll also try to build common testing requirements with the quality assurance behind them so that the test data generated through the process can be easily compared. Concerning PCP phase 3, here we'll already implement the full ETV process. That will mean that the definition of the intended application will need to follow the requirements of the ICO 14034 standards. So it will need to be expressed in terms of matrix characteristics, matrix meaning the material for which the technology is intended for. In our case, this is the hospital wastewater. We'll need to clearly define the purpose of the technology, basically speaking, what actually the technology is doing and how it is affecting the parameters of the matrix, and all the assumptions and limitations under which the technology can be implemented. We'll also make here the assessment of the environmental added value based on the available data. This could be also data that Luna will be talking in a moment in her presentations, referring to the sustainability aspects. The definition of the final performance claim and the specification of the performance parameters to be verified, because this will be technology specific depending on what actually the technology is intended to do with the hospital wastewater. And we will here follow the testing requirements according to ICO 14034. That will mean that the testing will need to be done by independent independent test bodies that are able to demonstrate compliance to 17025 requirements, and the verification of the performance will be then based on the test data produced in that way. That means that for the PCP Theresa phase 2, we will prepare common verification protocols and testing protocols that would allow to make the benchmarking against the KPIs. For PCP Theresa phase 3, for each of the verified 2 technologies, because there will be 2 technologies actually in that phase, maximum 2 technologies, we'll develop technology-specific verification protocols that will include the test design. And based on that, the test plans and the test reports will need to be generated by independent test bodies and provided to us while the test data is available. And for each technology, at the end, we'll generate a verification report and a statement of verification stating the actually achieved performance parameters of interest. I have been talking throughout this presentation about the KPIs. The key performance indicators are a part of the operational validation framework for the project. They are still under discussion. They need to be also confirmed by the buyers group. Nevertheless, we have come out already with an idea and directions into which those KPIs could go based on the analysis of the commercially available technologies, the state of the art, the innovative technologies that are under the pilot stages right now, and also the baseline conditions and expectations of the hospitals, the buyers group. So you can imagine that we'll be looking into KPIs that would refer to the technical and functional performance, focusing, of course, on the target pollutants to be removed by the PCP Theresa. Of course, something that would be related to the effluent quality parameters, the treatment capacity, the robustness of the technology under the different influent loads, and also the expected peaks of the flows and the content of the target contaminants, although we do not have this information yet. And also aspects related to reliability, the down frequency, and very important, the scalability and the modularity of the solutions versus the technical and functional performance. Of course, since we're talking about environmental technologies, for sure, we'll look into any KPIs that will be related to environmental performance and the sustainability. As said before, my colleague Luna will deep dive a little bit more on the sustainability aspects. Nevertheless, I don't want to spoiler her presentation. Nevertheless, you may expect issues related to energy consumption, water consumption, chemicals consumption, waste, noise, hazardous waste, other nuisance, this type of aspects. Operational KPIs that will be related to the constraints and limitations and needs of the hospitals. First of all, related to the size of the installation, the footprint, how easily this installation can be operated, what are the maintenance requirements, what is the automation level, so that it requires minimum effort for running, the monitoring capacity, and also the safety considerations for the staff. Costs are highly relevant, so for sure there will be some KPIs on the costs, on the regulatory and compliance. We'll also think about some KPIs because whatever technology will be delivered here, it has to comply both with the regulatory requirements that are site-specific. So especially that there might be some requirements from the hospitals and also from the wastewater operators on the installations themselves. and other aspects that are related to the discharge limits, for example. You may also expect some KPIs that will be related to the quality assurance of the whole systems, especially on the test data that will be needed for the verification. I think this is all from my side. I guess this gave you an understanding about our approach. Thank you very much.
Okay, so that was from Isabella. So maybe now, Luna, do you want me to share?
Yes, please. Can you share?
Okay. Okay, let me 1 second. Okay, tell me if you can see the presentation.
Yes, this is not my presentation. Sorry.
About this?
Yeah, it is.
Yes.
I don't know what's wrong with my camera. I can't seem to turn it on, but it's okay. I'm just gonna go ahead. Hi, I'm Luna. I am a project officer at Healthcare Without Harm Europe. Bear with me, I'm a bit sick today, so if you want me to raise my voice or repeat something that was unclear, please let me know. Feel free to interrupt me. And I will be asking some questions during the slides, so feel free to use the chat to reflect on anything you want. So as Isabella had already highlighted, I'm going to be talking about the sustainability assessment. What is this based on? It's based on life cycle thinking aligned with the ISO 14040 and 14044 principles. These are the LSA standards, if you're familiar with them. And we're going to rely on evidence from peer-reviewed LSA and LCC, which is life costing and social sustainability literature on hospital wastewater treatment, which I have to say is quite limited in literature right now. There are some emerging harmonization efforts for these kind of assessments, some peer-reviewed articles, some recent compilation of existing articles as well. And we're going to rely on the hospital inputs. However, I would like to highlight that what I will present, there has not been any final agreement made yet. These will be in another phase, which is the evaluation design, will be co-developed with hospitals and will be finalized in the next phase. Next slide, please. So baseline conditions at the pilot hospital, I am sure you've seen this before if you attended other meetings, but the common baseline is that the predominant routing is discharged to municipal sewers. Some hospitals do have existing stream-specific controls, like high-risk streams managed separately, or some sites reporting screenings and filters. What is the implication for suppliers? I would like to make it clear that most of the social environmental impacts that will be assessed in the sustainability assessment will arise only when the site units are introduced. And as Isabella had also mentioned, solutions must fit the hospital realities. Next slide, please. So this is a list of environmental dimensions to consider. As I said, they are still being discussed and they're not final, but just to give you an idea, first we have the energy used, which is a strong driver of climate emission and cost as well. Climate relevance, resource and material use. I saw in the previous presentation a link to also circularity, so that could make sense here as well. So using materials that are durable, water efficiency, water recovery potential, the ability to recover or reuse water, chemical and reagent use, waste sludge generation, formation of hazardous byproducts. This could sometimes be unintentionally done through wastewater treatment processes. And finally, ecotoxicity relevance. I know this is hard to quantify. I've been reading a lot of articles on this, and I see that there are still a lot of gaps in literature on how to do this properly, but we would like to explore it as well. I would also like to highlight that we are aware of trade-offs, so higher removal performance can come with higher energy or chemical or material burdens, and this assessment is meant to help compare these transparently, and I will talk about this a bit later on as well. Next slide. So from the literature, we know that energy use is actually the dominant life cycle hotspot in advanced hospital wastewater treatment. Across LSAs, this was consistently identified as the largest hotspot, especially in treatments like oxidations, UEVs, AOPs, which is advanced oxidized processes, and membrane systems. Pilot hospitals also in Theresa project also identified energy efficiency as a sustainability priority, and it's worth noting that some of these sites operate or plan to expand on on-site renewables like solar energy. And my question here is, do you have insights on what is the minimum energy intensity solutions can achieve in this high removal performance? So based on literature, what I found was low energy was in between, 0.5 or less. Moderate energy was between 0.5 and 1, and high energy was over 1. So we are looking to go towards more the low energy, but I would like to hear some of the opinions and reflections on this. Thank you. Next slide. Social sustainability, what is this about? It's mainly about safe, acceptable, low burden operation. Social evaluations in healthcare hospital wastewater treatment are limited. Indicators are often qualitative and very context specific. So what are we looking at here? Worker safety and training needs. We want to make sure that workers are aware of all the safety procedures, and we also want to make sure that the workload and operational complexity remains feasible for hospitals. We know a lot that hospitals cannot take on more workload. Social acceptability in hospital settings, so this relates to the noise, odor, footprint, and siting constraints. It relates to the operational KPIs. Public health contribution, the reduced release of ARBs and ARGs and hazardous residues can be framed as an expected contribution, not as epidemiological proof, but the reduction of AMR in general could be a public health contribution. Responsible business conduct and human rights due diligence. So these are supply chain expectations, of course, that we expect suppliers to have. And finally, something that's a bit exploratory but worth mentioning in social sustainability is gender and inclusion. So inclusion in design and training as well. Next slide, please. Finally, we have the economic affordability, something that Isabella also highlighted. So costs vary widely, we are aware of that, but affordability is one of the feasibility gates for this project. How do we approach it? We have the CAPEX, which is the upfront investment in treatment equipment and installation, and the OPEX, which is the costs that come with electricity, routine maintenance, and so on. What are some of the economic drivers that are mainly present in literature? We found that energy demand, consumables and media replacement, and maintenance and staffing time, and finally, high-cost components can dominate in specific wastewater treatment technologies that are presented, like ozone generation equipment. So all of these drive the economic cost within the treatment. Next slide, please. So based on some of the literature, I will not go through this in detail, but I found some studies from Denmark, which are quite old, but they use UV disinfection, and it has shown really low OPEX. There's not a lot on CAPEX, which is the upfront investment, but there's more literature on OPEX, which is what comes later in the prices. Meanwhile, you can see here up to one is the power activated carbon and membrane bioreactor, which consumes more electricity probably, and it's a mixed type of solution, so it's not only one. and it can go up to 2.5. This was a case study in Italy of submerged membrane bioreactor and ultrafiltration. So costs go up depending on how much there is combinations or what kind of electricity demand they need. And I'm just asking if this looks realistic. You can also share your thoughts. Thanks. Next slide, please. So what we're trying to do here is that we are aware of all these trade-offs, and what helps us guide our assessments is a benefit burden thinking. So we will look at both the added value, as Isabella mentioned, in terms of environmental added value, and what are the benefits socially, economically, but also the burdens. And we can see in the assessment later on how this will be balanced. We know we are aware of some trade-offs like transformation products, unintended byproducts, or high removal performance leading to higher energy burdens. But all of this will be taken into consideration. And I ask again the questions, what are the biggest trade-offs that you foresee? Next, please. I think this is my final slide. No. Yeah, this was my final slide. Thank you very much. And
Yes,
feel
yes,
free
it
to
was.
leave anything in the chat and reflections. Thank you.
Okay, perfect. So for the final part of the technical aspects is Diana, do you want me to share?
Yes, please.
Okay,
Thank you very much.
perfect.
So meanwhile, I introduce myself. So my name is Diana Cortés, and I'm manager at Silo, a Spanish consultancy based in Madrid, specialized in innovation procurement. For the Theresa project, we are responsible for the exploitation and adoption strategy. So thank you, Bartos. So first, I would like to briefly explain how exploitation and adoption are addressed within the Theresa project, with a particular focus on the intellectual property rights under the pre-commercial procurement. You know, this is the approach we are having in this project. So for the PCP model, is built around a key principle, which is risk and benefit sharing under market conditions. So this means that both public procurers and suppliers share the risk and benefits related to research and development activities, especially when it comes to intellectual property rights. In practical terms, this approach provides both protection and incentives for suppliers. So project beneficiaries retain the intellectual property rights they generate while ensuring access to any necessary background knowledge for other participants involved in this PCP project. On the other hand, PCP providers also retain ownership of the results they develop. In return, the buyers group is granted several important rights. The first one is a royalty-free license to use the results for their own internal purposes. And the second one is the right to request or to grant themselves non-exclusive licenses to exploit the results under fair and reasonable conditions. There is also a public interest safeguard known as callback right. This mechanism will only be applied if exceptional circumstances, for example, if the results are used against the public interest or if they are not commercially exploited within the agreed time frame. In such cases, a following consultation would be done with the PCP providers. The procurers may require the transfer of the intellectual property rights ownership. Overall, this framework is designed to stimulate innovation, provide legal certainty for suppliers, and ensure that publicly funded R&D leads to tangible and reasonable market outcomes. So moving to the next slide, please. I will also outline how this IPR framework is supported by a structured exploitation and adoption strategy in the case of the Theresa project. So the overall objective is to develop a comprehensive action plan that supports the final adoption of the solutions. This plan combines tailored strategies both for procurers and suppliers with the aim of ensuring successful exploitation and long-term sustainability. For suppliers in particular, which is the focus of this webinar, the strategy is organized on three main phases. So the first phase is the early engagement and orientation, which will start from January 2027. This phase includes webinars focused on business modeling, funding opportunities, and go-to-market strategies. The aim of these webinars is to support suppliers early on in understanding the commercial potential of their solutions. The second phase, the validation and tailor support, which will start in January 2028 and go onwards. During phase 2 of the project, individual follow-up sessions will be provided. These sessions will help suppliers refine their exploitation plans, strengthen their business models, and prepare funding application. The third and last phase is the consolidation and market adoption from April 2029 onwards. In this final phase, the focus will be on consolidating business strategies, facilitating access to funding, and ensuring readiness for commercialization and market uptake. Through this step-by-step approach, the Theresa project aims not only to develop innovative solutions, but also to ensure that they are successfully adopted and create real impact in the management of hospital wastewater. So I think that's everything from my side. Thank you very much.
Thank you so much, Diana. So now it's time for the explaining what is the OMC and what events and what's coming next. So maybe Sophia, do you want me to share the screen?
Yes, please.
If it is for me, I prefer to do it myself.
Okay, perfect.
Oh, Sophia's going.
Okay, good morning. Sorry, one sec. I'm trying to share my screen. Could you see it?
Yes.
Could you see my screen and could you see my presentation?
Yes.
Okay. Then good morning to everyone. We are in the open market consultation of Theresa. And first of all, what is an open market consultation and why are we here? As it has been mentioned on the event today, Theresa is defining a problem shared by several hospitals in Europe for which they have not found a solution in the market already available. For this reason, we are launching a competition for the market to answer to develop a solution for the unmet need that has been defined by the group of buyers. The need that the hospital share is defined in terms of functionality, not in terms of the technology solution. Is defined in terms of functionality and expected outcomes. But at this moment, we have done a research about the state of the art, but still we need to establish a dialogue with the industry to know if our expected solution is too ambitious and unfeasible, or if it is not ambitious enough, and it's because we need our solution to be future ready, because it will start to be commercialized not sooner than 4 or 5 years from now. So it has to be ambitious, but at the same time feasible. And we want you, industry and research ecosystem, to let us know if our assumptions are correct. Then the main goal of the open market consultation is to open this dialogue to know if our requirements are right, if the budget is adequate, if the timeline is reasonable, and to understand the market dynamic from our side to make all the story coherent. We also want to inform you all about the coming tender to guarantee that you all understand what are we looking for and to foster your participation in our tender. And because the solution that we expect for our current problem is not straightforward, we assume that most probably you will need to create consortium to participate on it. So we also have a matchmaking tool because to facilitate the matching of different companies to answer our needs. Who can join in our open market consultation? Ideally, we expect all stakeholders in the ecosystem to contribute. Indeed, most participant expected came from the industry, all size of industry, disruptive startups, SMEs, large industry, integrator. We expect to have research institutions and technology center, universities, etc. Environmental and water sector organizations are mostly welcome. Other colleagues, hospitals or utilities involved in water that could become potential adopter of our solutions in the future are welcome as well. And also those companies with or entities which will act as integrator or intermediaries are also welcome. What the open market consultation offer? For suppliers, you can know firsthand what are our needs and priorities from our team of procurers or buyer. You will start to receive information about the coming commercial procurement. Your entity will start to be known for our buyers and also for the rest of the industry and for the community. And the most important is that your feedback will influence the preparation of the coming tender. So they will be better tailored to what you can offer. And for procurers, as I said, we need to be sure that what we are asking for is aligned with what the market can offer with a future-proof readiness. And we need to obtain information from the market that we were not aware of that through our desk research, and to make any potential bidder aware of the coming opportunity. How is all this prepared? Well, we have had several events, and this we plan to have 5 events like this one, which is the last one, to present all the information related to Theresa. You can see previous one in you can access to the presentation in our website. In each of the event, we have focused more on the specificities of the hospitals in one of the countries participating in Theresa, and also in a thematic focus. Today, we have made the focus on verification, validation, and exploitation, but you can have also more detailed information on the topics defined that you can see in the slide: introduction to PCP and tendering, state-of-the-art functional and technical requirements in the one in Poland. So you can explore all this information into our website, and we will have a final event, February 26th, to explain what has been the findings that we have got through the open market consultation. I will show you now the matchmaking tool that you can use to find your colleagues to come into our tender that will be open until the tender, we open the possibility to have pitch session in our events. You can find also all the pitches in the recording. The opportunity to have bilateral meeting will be opened in February. And our most important, or one of our most important tools is the questionnaire. Please spend some time to contribute tailoring our tender to your needs or to your opportunities by filling in our questionnaire. We will go in detail on it a little bit, and now I will go on detail on it in a few minutes. Well, how we can collect feedback from you, the questionnaire that I will explain now, the company pitch that I mentioned, and we also have a section for questions and answers. That all the questions that will be made through any channel, through the events like the one today, through the official email for question and answer, or even those into the bilateral meeting, all of them will be published. So everyone will have access to the same information. And the official answers will be those that will appear in our question and answer platform. So now I want to show you a couple of things. If you go to our website, theresapcp.eu, you will find an open market consultation click. Here you can find the OMC events, the frequently asked question that I have just mentioned, and then you will find here this scope and questionnaire. The scope is a document where you can find all the information that is now available about Theresa. You will need to download and to read this document to be able to answer to the questionnaire. If you go to the questionnaire, it is built on top of the OMC survey, that is a tool from the European Commission. You will find, sorry, there is a small section with mandatory field. It's very small, it's only your affiliation. And for the rest, it will be optional. But please give us as much information as possible and concentrate also on quality. So please don't fill those sections for which you think you don't have the right information, but give us as much as you can. It will be positive for the whole community. As I mentioned before, we don't expect any single company to be able to provide the full solution. We expect that you create consortium to give us the complete solution. So we expect to have several modules addressing our needs. If your company will provide more than one, then please fill more than questionnaire, because this tool didn't allow us to provide sections for several of them. In case you will find that sometimes maybe there are tables asking for precise information that we need to define the threshold that we will ask for into the tender documents. If you have this information in a file, then please just upload it and we will extract the information from there. We don't expect you to type if the information is available in another way. If you find that there is something that we didn't ask, but that is relevant, Please also let us know by uploading a document or by filling in the open boxes that we have left in the questionnaire. There is space to give additional information, and please, you are the expert. Please let us know everything that we need to know, even if we were not aware. Don't forget to go to the very end and to fill this captcha and to submit. Otherwise, we will not receive it. In case you want to have the template, a Word template of the survey, because you think it will be easier to develop it out and not online, just send us an email to the official address, and we will send it to you. Please, and then if you coming back to the website, if you go here to the matchmaking tool, you will see some of the companies that have already described their profiles, and you can where you can find partner to your proposal. Well, coming back to the OMC, it is important to emphasize that the contracting authority may not disclose any technical or commercial information that may have been provided by the participant, which they have designated and reasoned as confidential. The suppliers must identify the documentation or the technical or commercial information that they consider to be confidential, and it is not permissible for them to make a generic declaration or declare that all documents or all information is confidential. Participants may designate some of the documents submitted as confidential. Please send us as least confidential information as possible. Send only the information that you consider is important and relevant for us to know, but we prefer don't manage confidential information if possible. Be aware that participation in the open market consultation does not constitute a condition for participation in any subsequent procurement procedure and will not result in any advantage, preferential treatment, or prejudice in the context of any future tender or contract award. And this is all from my side. Pleased to be here, and sorry, and please fill us our questionnaire and participate in our matchmaking tool. We are eager to know more about our proposal from your side. Thank you very much.
Thank you, Sofia. So now it's time for a brief context for the hospital. So maybe Erna, Ben, or someone want to...
Yes, I will do it.
Okay.
Marcus, can you share the screen? And then
Yeah.
I will tell you when to click. Yes?
Perfect. Okay, wait a moment. It was the whole screen. Okay.
Yes, Niall. Welcome. I will highlight some specifics of the Maastricht situation we are in, which is maybe relevant for the companies who can help us seeking solutions. Next slide, please. Well, the water situation in the Netherlands is not good. We are a delta. If you look to the fresh water bodies in Europe, we are the worst performing. And this is not only due to bicycles, which you find in every water, but of course also to chemicals. And also, of course, we have nitrates of many animals in the country. But medication also is important. Next slide. Here we see in red where Maastricht is located. We are along the river, the Maas, the Meuse. And this river is very important in the Netherlands for the generation of drinking water. About 7 million people get their drinking water from the River de Maas, and of course, this in the summer, it can be, the flow can be only be 20 cubic meters per second, which is very, very low. And there are many major cities along the Maas, and then the water becomes very, very dirty. And sometimes they have to stop the intake of water. And there are, all the way you see the blue water drops, these are intake places for making drinking water. And that's important for the Netherlands. For the next slide, so this is, please next slide. So there is the Riva Maas. I have measured 104,000 chemicals, measurements along many chemicals. And you can see there were about 694 really of the ones that they do measure that exceeded the thresholds. And the orange ones are medications that are mainly used in the general population. There are no hospital medications on this list, so we do not know. Next slide. Here you see a picture of our area, and you see a list of chemicals. These chemicals are the general medications, and as Erna told in the beginning, about 3% in the Netherlands on the average. The wastewater treatment plant receives these medications from the hospital and 97% from the general population. Please click, Bartos. This is our hospital. The next click. There is our wastewater treatment plant. You can see the sewage lines, and then click again. We are relatively a large hospital, and we have only a few inhabitants. So we actually, Maastricht, this wastewater treatment plant is the hotspot of the Netherlands, where hospital medicines enters a wastewater treatment plant, and we can measure, and that's what we're doing in some research studies. We measure the amount of chemicals, and we found, based on these chemicals, that was in 2019, that we, not 3%, we are over 10%. But when I looked at some specific hospital medications, for instance, the contrast agents, we are 100%. So that varies a lot. And the chemicals that are on the list, which we would like to have in the tender, contain many hospital selected medicines, but also some, well, we also have to, of course, comply to the urban wastewater regulations. Next slide. And this is our wastewater treatment plant Heugem is not a specialized wastewater treatment, and when we measured at that period of these medicines, only about 21% was removed. So we're doing not really good. So that's why we want to improve. And certainly, and we think that hospital selected medicines should be not filtered at a wastewater treatment plant, but more closely to the source, which is in the hospital. The next slide gives you an overview of our hospital. And in gray, you see the nursing wards. We have, there are about these 500 beds, and there are many different departments. We have our outpatient clinics are in the other bar, and there are 3 levels of it, and the nursing wards have 5 levels. Next. Click next, please. And there are also laboratories where we do all kinds of things. We have our surgical rooms, and then we are, for the radiology department, we have 2 locations. We have imaging, and we have CT imaging, and we have MRI imaging. On the outside, you can see the area is already fully built. There's little space for a huge plant or something else. So we are in favor for a decentral solution, maybe small ones that can be placed indoors, or maybe the processing can be at another location. We are also in favor for the high emission departments. So that could be radiology for the contrast agents, the ICU for the antibiotics, which are on our list, and oncology for all the drugs that are used for treating cancer. What we like to do is, of course, to find solutions that limit the emission of the hospital. And we would like to combine it with research that we will measure, hopefully at the same time when this is installed, one of the solutions here at the wastewater treatment plant, whether really what we are doing is also contributing really to what we emit to the river, the Maas. So that's one of the things we would certainly like to do. And now there is maybe what we like to have for a solution. We will rebuild the patient towards the nursing wards. That will happen in a couple of years. That has not exactly been defined, but that creates maybe some opportunities, maybe to make different sewage lines specific, maybe for urine or separation. We would like to hear your ideas about what can be done, or maybe, etc. And also the radiology department, which is now split at different levels, will be built at one location or rebuilt in the current situation. And also when we start rebuilding, then maybe new opportunities come up. And I think the solution we would like to test here should give us an idea whether that's a really, if you would like to do the whole rebuilding in that case, would be very cost efficient and also good for us, our sustainability. I think with this short summary, I hope to give you an idea of what is in the in Maastricht. What I said now in the presentation, there are some details in the text slides. I'm not going to read them. You can see the amount of water we have exactly, more or less what is in it. You please click on next. So I'm not going to read these slides. That is what you can see. We have about 330 cubic meters a day, but at these central places, maybe at some parts it may only be 5 cubic meters a day. So that really depends on the solution and for which department we are looking for. And here it's specified that we have a limited space on the outside. And for the regulations, there are not, our current sewage, we do not have any regulation at all. The sewage of the hospital just flows unfiltered to the wastewater treatment plant. And of course, there are some regulations which are national regulations. And we also do not want to reuse our water because our rainwater is contributing to this, and we do not have a grey water system in hospital installed. So that is not a solution, but our non-potable water could be used for the new garden we are planning to build on the garage, etc. So we may use, of course, that water for other purposes. I'm happy to answer questions in this direction. And with this, I would like to close my presentation. Thank you very much.
Okay, thank you so much, Ben. So now it's time for the company pitches. So maybe Matish, we can start with you. I'm changing you to the moderator status so you can share your screen.
Yes, good morning. Matthijs Maris-Siro here. I was actually wondering who did not see my pitch yet, because most of the people I see in the call, they were there in the last presentations as well, and I know Maastricht University Medical Center quite well. So I don't want to bother your time too much. So the only thing I'm going to show you, which most of them do already know, is a picture of what we built already. We have a strong evidence in creating machines very close to the source, which are most of the time toilet or sanitary based systems, and those systems remove already contrast media, ICU, all kind of medical residues, nuclear medicine, etc. So this may help the project, not really because we are at a very high TRL for that, but of course we are aiming to join because we see, of course, always more development potential, and therefore we are interested in joining the Theresa project. However, it's a bit of a puzzle how to join, and I was a bit amazed that you are announcing it as a project that there is no current supply to the market. I know for sure that we are not the only solution, and you need more than only our solution. But it's very good to know that we can, at a department, at a specific patient level, or even in a new department that is built, like Ben was already referring to it, with urine separation, etc., take out a lot of special medical excretion that, for example, takes place in the radiology department or in the ICU department. And I think the nicest thing that we add to this is that we created a circular process of our filter technology that allows not only to remove the substances from the wastewater, but also to reuse the raw materials that are inside, like iodine or gadolinium, when we talk about contrast media. I think this is all for now, and thank you for your attention.
Okay, thank you so much, Matish. So now I will give to Jacob the moderator status, so he can talk. And if you want me to share the screen with the presentation, perfect.
Thank you. I don't know. I can share the screen, no problem.
Okay.
Or you can share. I don't mind. All right. All right. So that's we can probably start with the first one. Hello, everybody. I'm the first time at this meeting, but you might have heard about our technology from the presentation of Dr. Sergey Preis from Tallinn Technical University. And here I'm to present the OMC company, which is based in Finland, and it's a partner of Tallinn Technical University concerning the piloting and hardware and all the equipment. Could you switch the next slide, please?
Yes. I'm trying to put in the presentation mode, but meanwhile.
All right, great. So our technology is basically the oxidative technology. We deal with impurities in water oxidized by different active radicals produced by electrical discharge plasma. In our system, the water is basically showered, so it's dispersed into small droplets and showered through the area of high voltage electrical discharge plasma. And this plasma is a source of active species such as hydroxyl radicals and atomic oxygen and ozone. And these species are, they produce oxidation, so they destroy organic substances, they disinfect water, they may also oxidize inorganic substances. And we have done a bit of piloting recently, so we have several pilot devices. Could you switch it? Next slide.
Okay.
The next one.
You can, yeah.
The next one.
Okay.
So, that's the previous one. The previous one.
Yeah,
this one. So we've been working with hospital wastewater as well. So we had actually 2 pilots in this area. So the first pilot was in South Karelia and the quite big central hospital in Lappeenranta, and we have managed to remove majority of the pharmaceutical residues from this water, although the power consumption was actually quite big. And the second was especially good. It was in Rinnekote in Espoo. This was a nursing home, and here we also managed to remove pretty much 90% of all the pharmaceuticals from the wastewaters, and the power consumption was really small. It was around several hundred watts per cubic meter, which we consider actually quite small. This here the figure is 300. The flow of water was around 300 cubic meters per day, and the concentrations was like several to tens of micrograms of different substances per liter. In this, could you move the next one? In this piloting test, we have actually found that the oxidation technology is extremely efficient in removing the dissolved substances. Soluble, we can have in this hospital wastewaters, we basically have two types of pollutants. The one is pollutants which are dispersed, some matter, like particles in water, and the second is soluble substances. The insoluble forms are better removed with different kinds of separation, like coagulation or membrane filtration or anything like settling. And in our experiments, we have found that if a substantial amount of insoluble matter, like turbidity, is present in water, like you can see on this picture, then the efficiency of oxidation is dropping quite a while. But if the substances, if the pharmaceuticals are soluble, they are quite efficiently removed. And in our case, we also deal with water showers, so that we have tiny droplets, small droplets of water in the plasma zone. And if the pollutants are of hydrophobic nature, they tend to move to the surface of water, which increases the efficiency of the treatment. And also we produce the oxidants in situ, so they are produced straight in this water shower flow in very close proximity to the impurities. So this also improves the efficiency of treatment. But in this case, we're talking about multi-stage treatment. So we have, could you please make the next slide? Yeah, so the first stage of treatment should include the removal of suspended solids. First the oils, of course, and then the suspended solids, preferably with coagulation. So we're removing them quite efficiently. And then the clarified water is treated by oxidation, destroying the dissolved pollutants, dissolved substances. Well, then actually we have the pharma-free wastewater that can be disposed to municipal sewage system. Several questions here are that we are basically the producer of the oxidation equipment, so we need a partner who is helping us with the clarification stage. Also, the sludge has to be disposed of or somehow treated on spot, so we need some solutions for the sludge treatment as well. Then also, yeah, could you please move to the next one? The next one, yeah. Then we also would need a partner to assess the concentrations, to measure the concentration of the substances in water. So basically, we are open for cooperation, and here it would be nice to have a consortium of several partners dealing with this water, so we have an efficient means to remove the efficient technology to remove the dissolved substances. We need somebody to help us with the clarification, with the separation of suspended solids, and then the sludge treatment and chemical analysis. Would be also nice to have a partner for this. Right, so then that's probably, could you move the next one? So how is it going to be in practice? So here on this picture you can see one of the pilot devices that Voxy has built. This was used actually for different chemical industry applications, but it can be used for pharmaceuticals as well. So our device is installed in a 20 feet sea container, so it can be deployed on site. So we can provide the device for the hospital. Then we need a partner to make the analysis and to make the research support. And this will most probably be the Tallinn Technical University. So you have heard presentations of Dr. Price, who's very good at the chemical part. And also we probably would need some other partners need to search for. So yeah, we have actually, could you move to the next one? We have quite a long experience of pharmaceutical removal from wastewaters. Here we have just the latest publications made by Dr. Trace and Darwin, also members of our company. We've been dealing with antibiotics and different kinds of carbamazepine and hormones. So I think that on our part, we have gained substantial experience on that. Well, that's probably all I wanted to say. Thank you for your attention.
Okay, thank you so much.
If you have any questions, please feel free. Maybe writing in the chat.
Perfect.
Or contacting us directly. I don't know if we have any contacts in here, probably not in the presentation, but anyway.
Yes, because now it's time for the Q&A part of the event, but I don't see any question in the chat or in the Q&A section. So maybe Maastricht, if you want to take into the stage to close the event.
Yeah, well, thank you everybody for explaining the different components of this PCP Theresa, how it will work, all the legal and regulatory requirements we have to do, and also I would like to thank the companies for presenting their pitch. I think we will look again to the videos that will be uploaded, and then with the teams we will deliberate and come back on February 26th together to see what this open market consultation has resulted for us, and from then on we will work on the tender. I would like to thank everybody for his contribution, and I wish you a very nice and pleasant day. Thank you very much, and I close the meeting.
Thank you.
Buffers, can we stay a little bit? Just two of us, or I don't know whether, or maybe John.
Okay, maybe in another meeting link.
Another meeting, okay.
Yeah, thank you. Bye.
Thank you all. Bye-bye.